Okay, I'm going to go ahead and get started. Plan for today is to finish up the lecture material that I didn't get to on Tuesday, which is really just the ethics part of that lecture in terms of guidelines for using AI, responsible use of AI. And then we're going to do some Unix. So we're going to move on to bridges. I'm under the assumption that everyone can log in to bridges through on-demand. So for starters, this is kind of where I ended. I jumped to the guidelines at the end. One of the things that I didn't mention that I meant to is this terminology. It was first introduced in this 2024 paper, which got quite a bit of traction, the AICICA. Artificial Intelligence Chatbot-Induced Cognitive Atrophy. So that's the is AI making you dumber that we talked about. And I said that the jury is still out on this a little bit. There's certainly some evidence. This paper has a whole website associated with it. This is the most recent one, the Kasmina et al. Paper, where they showed that people who used ChatGPT to write essays for them had less brain connectivity in their MRIs. Right, so there's something functionally happening in their brains when they're offloading the essay writing task to ChatGPT. Was interesting though that, right, I talked about how they switched it in the fourth round of the trial, where they did 3 rounds where there was a brain-only group and a ChatGPT group. And then for the last one, they flipped it so that the brain group had to use ChatGPT and the ChatGPT group could only use their brains. Well, there wasn't really a huge decline in the ChatGPT group or increase necessarily, but the ones who had to use their brain 3 times and then switched to ChatGPT actually did better. So there actually may be a timing issue, and my conclusion that I talked about Tuesday was, it's important to learn to think critically first, and then ChatGPT can be a very powerful tool. And for this class, I'm going to work under the assumption that you have some background in critical thinking. So, safe or not, that's the assumption I'm making. Okay, so the second goal here was to understand ethical issues, and these get to why the guidelines are the way they are. Disclose what you use AI for, okay? So being transparent and disclosing. And when you're disclosing, important to say what model did you use, how did you verify the outputs. Right, if you just tell me that you used an AI tool, and you don't tell me that you did anything to try to verify the truth or correctness of your answer, I'm going to assume that you don't know if you got it right. Integrity and attribution. This is a big one in science, right? Unattributed AI text or code is plagiarism, right? You copy paste the result of ChatGPT and don't disclose it, especially. That might as well have been copied from another person. That's plagiarism. That is an honor code violation at UTA. Okay. It's all about the attribution, though. I'm not saying don't use ChatGPT. I'm not even saying don't copy paste. You just have to tell me this is copy pasted from ChatGPT. Okay. And then, really, a sort of bigger issue that has been a debate in academia is, is AI an author? If it does some heavy lifting, even on parts of a grant or a paper, where do you put that attribution? Is it on the author line? The answer is no. And where this really why that decision is made is that AI can't have responsibility for the content. Authorship implies something about the responsibility for the content in the paper or the grant. AI is not responsible. You are. The person is. Okay? And so that's why AI doesn't get listed as an author. It gets put in the methods or in the acknowledgments, but not on the author line. Okay? And then I've given you this is becoming increasingly common to see something like this, an attribution statement or a disclosure statement. That's just a generic template with some spots you might fill in to disclose your AI use. Again, we're talking about the ethics of AI use. Honoring consent and data use limits. So I talked when we were talking about the risks of uploading data or sometimes mixing your labels, accidentally uploading labels. Especially if you're dealing with human data, you really have to be careful about what gets disclosed to the AI tool that you're using, okay? That's what this is all about. Usually, well, not usually, always, if you're going to do human research, you have to go through training. UTA has its own training set up to be approved to do any kind of human research. Even if I wanted to treat, like the revamp of this class, right? If I wanted to treat this as a study and sort of do some testing on you guys about, how's it going, I would have to go through human participant research training, okay? I'm not treating it as a study. But it's quite heavily regulated for very good reasons. So when you design a study and you're trying to get approval for that, you do something, or you send a protocol to the Institutional Review Board. There's a committee at UTA that reviews those and makes recommendations based on, ultimately, there's a do not harm or do no harm policy, sort of like in medicine. So anyway, when you're using AI, you need to respect all of those rules and all the protocols that are approved. Anytime you want to do something that's not explicitly in your protocol, the assumption is you can't do it, right? If you figure out during a study that you need to do something different, you have to go back to the review board and get your protocol modified before it's okay to do that, okay? And this is a sort of a new problem, right? If I want to ask ChatGPT a subtly different question about my data that wasn't in the protocol, you can have expedited review, but you have to have it reviewed, okay? So this is sort of tied to that, the fairness and harm reduction. This goes along with thinking, often this is in the proposal stage where you're anticipating who's benefiting or who might be harmed by errors and biases. And this also goes to, if you get to a stage where you're training your own models, we talked about one of the potential risks is training bias, okay? And so thinking about who might be harmed or if there are errors in the bias, or errors in the training set that cause bias. The example in bioinformatics that is probably the most pervasive is that genome-wide association study data is hugely European-centric, okay? And so if you were going to train data on what we know about genome-wide association studies, if you're not of European descent primarily, it could make very wrong inferences about causation in the genetics because the training data just isn't there. We talked about the risks of, model system, non-model system inference. It carries over at all kinds of levels because it can only tell you about what it's been trained on. those connections. A lot of this comes, back to the transparency and attribution, right? Saying which model you used, and anything you did to try to avoid the biases are important, because at least that makes it reproducible, right? And that reproducibility, thinking about that as an ethical duty, right? We'll come back to this a few times over the semester. Because in bioinformatics, especially if you're at the cutting edge of method development, lots of times you'll see in papers where it's becoming less common, but for a while you would see in-house scripts as a tool, right? They're not published anywhere. You can't tell what was in them. That is not reproducible. And it is super frustrating if you're trying to reproduce what they did or trying to implement the tool that they used and you don't have all the steps, okay? So making your code or your analyses as reproducible as possible, thinking of that as an ethical duty, I think is a good idea. And so keeping an audit trail, if it's ChatGPT, for example, it's keeping the prompt history for you. But then also, if you're not in ChatGPT, you've got to do a little bit more on your own of just keeping good records. It's like a lab notebook if you're in a wet lab, right? You got to think about doing the same thing for your computational work. Okay, I already talked about the course guidelines, right? Any questions about this stuff? I don't remember if I talked about the practical do's and don'ts, but they're there. PII and PHI, these are the personally identifiable information and protected health information. They're just the acronyms you see all over the place when you're dealing with human genetic data in particular. I really want to get to Unix, so I had planned to do some examples where people have been in trouble before, and not super important. So I'm gonna skip that. We'll probably circle back to some of these too. So especially when we get to projects. Okay, it'll also be more meaningful when we get to like you're actually having this ethical dilemma or this question about how am I using AI too much for this project. Okay. Questions about risks and uses? Got a great question from Jada. Is that you? Yeah, by email about like where do I go for information, and she had a specific question about the sycophancy issue. That one I sent her a link if you're interested. Just message me or send me an email. I can send you that. What OpenAI said about the problem and what they did to remedy it. A lot of these ethical issues, OpenAI tries to live by too. Okay. To an extent, right? It is a company with proprietary information, so they're not going to tell you exactly what's going on behind the machine, but they're going to tell you the result, what they did to test it, and what they did to remedy the problem. But in terms of reliable sources of information, this is a societal question. I don't trust any secondary source. I mainly use probably the same tools that most, Google Aggregator is my news source, Google News. It just aggregates all the sources, and it learns my preferences, which almost everything online does now. But if it's important, I always try to get as close to the primary source as I can, right? Trying to get to either the primary literature paper or at least to an interview with an author. So like going to the source. And if it's something that I feel is like not close enough to my wheelhouse for me to really make a educated judgment, I explicitly go looking for opposing opinions. And especially reading, like I try to force my algorithm to be balanced by picking sources that I know are probably going to disagree with my bias. And so seeing what they have to say, because that does affect the aggregator. So anyway, those are not bioinformatics necessarily related questions as much as how do you digest information in a world where AI is everywhere and it knows you sometimes better than yourself. I think most people are aware of this today. Okay, so you're going to need both of those files. So this is Module 2 lecture content for Thursday. I'm going to start in that tutorial document. We don't need the file immediately, okay? And this was a good question earlier. Don't extract that file on your computer. I mean, it's not huge. It's not going to crash your computer, but we're going to learn to unpack it from the command line. So most of the rest of the day is going to be work at your own pace through this document. Okay. Couple words of intro, just, you know, bioinformatics is one of those fields that covers so much. If you ask 10 people, they'll give you 10 different definitions. There's a really heavy emphasis in this course on sequence analysis, DNA and RNA sequence analysis, because that's what the majority of students in our department and faculty in our department need their students to be able to do. If you were in say the biochemistry department specifically, you might do more protein folding stuff. We're not going to talk about protein folding at all, although it's a very interesting area for AI use especially. So that's just the what we're going to cover and why. Learning to code, like learning any other language, we're going to kind of pick it up slowly, although it may feel like you're drinking from a fire hose. I've used that analogy, I think this is the second time now. We're going to do all of Linux, all of Unix and Linux synonymous in my mind. So if I say one, I mean both. We're going to cover all of it today, and we're going to cover most of Python next week. So buckle up. Large language models, other tools can be super helpful. Seems archaic now, but there was a section in this document last year on using the man pages. That man short for manual, right? So looking up the help documentation, which was terrible, super hard to read and understand. Now ChatGPT can just tell you what it means in normal human language. So then you get to this question of why learn to program at all? And I skipped over this part about, like, if I really wanted to teach you to program, I would take a lot longer. You could take a programming class, whatever. For most biologists, which is the main audience of the class, although not the only one anymore, You don't have to be fluent to be functional, right? I think the better you get at coding, the more it will help you, especially if you're in a lab who does a lot of computation or generates a lot of sequence data, because some of the stuff, hopefully, that we talk about are going to give you ideas for novel ways to approach your data. So why learn to program? I think it makes you a better thinker. I really do. I would say that after teaching this class for a while, I'm more and more convinced that I can predict how well you'll do in grad school based on your performance in here. Can you break a problem down and think clearly about it? Can you troubleshoot it? The way you troubleshoot code totally translates to can you troubleshoot PCR, okay? It's breaking it down, isolating the variables, and just tweaking one variable at a time so you can make progress. I already mentioned the lab notebook thing, but creating tools that are reproducible and auditable in some sense, that your analysis now has a sort of concrete record. Somebody can go back and reproduce what you've done. Learning customization and edge cases. So this is, for example, when you're using ChatGPT to help you write code, if you know something about programming, it will be more efficient, because if it's not doing what you need it to do, it's giving unexpected results, being able to look at the code that it's giving you and have some idea of how, like, why it's going wrong, will make that collaboration way more efficient. Think about the closer you can get to speaking the same language as somebody else, the faster the communication can happen, right? Go to a country where you don't speak the language, and trying to figure out how much something costs or haggle over that takes a lot longer than if you speak that language, okay? Maybe that's a terrible example, but quality control. They're good assistants, but imperfect scientists. Knowing how to code will help you, again, get to the answer quicker. I think it's important maybe to always have in your mind that it really, even though it seems like it understands your data, it really doesn't, okay? And you'll see it, I gave the example of mixing up DNA and RNA and the risks, okay? It can do, like, that's the level of it doesn't really understand, okay? To me, that seems like a very fundamental, like, first question you would ask. It will just go on and analyze it and not think about it, right? I will always talk about ChatGPT now like it's a person. Data stewardship and ethics, so understanding what your code and tools actually do. This is the example where you've asked ChatGPT to do some kind of analysis or code some kind of analysis for you. It's given you the code, it works, but you don't know how it works. That's a dangerous place to be when you put your name on the author line, okay? So knowing how to code will help you understand what the AI has done. And then career resilience. There's still, even though it's hard to argue, I wouldn't argue my own kids go into like coding only, but the tools change, and conceptually understanding how to code is still a very valuable skill that it translates. And part of that goes back to the efficiency issue of speaking the same language. I think, like, from where you're sitting, AI has come a lot farther to be able to speak your language than you probably have, many of you at least, to speaking its language, right? So, and it's moving much faster in our direction than we are in its direction as a whole. But the more you can move in that direction, just in terms of career resilience, career opportunities, I think that makes you more marketable. So the bold part there, we're going to treat it as a lab partner and a tutor, not as a genius on whom we can offload our effort and thinking. No cognitive offloading. Try to understand what it's doing, what it's telling you, and attribute it when you do use it. Okay, and then this is really where I'm hoping to get. Moving between biological questions, which we're really going to talk, we're going to talk about file manipulation and stuff today. So hopefully or at least, I don't know if you'll get all the way through this document during the class time, probably not. But by the end of this document, you can do some cool bioinformatics stuff. You even ask about intron positions in a genome file. Ask some cool file parsing questions, I would say. But when we move into Python, we'll start translating. Actually, I want to know where the origin of replication is in this bacteria and turn that into a computational question, not just a wet lab question. And so by the end of the course, hopefully we can sort of move between the biological question, the coding, sort of Unix, Python, what we'll be doing, and then the AI-assisted stuff to help translate those biological questions into some cool insights. Again, really excited about what you guys come up with for projects. Why learn Unix if we have open on demand, right? We're gonna move right to the GUI in a second, and then open your terminal. On demand is really just a gateway. You'll appreciate this, I think, by the end of the slides, but I just wanted to motivate it from the beginning. These are the questions I ask myself, like, do I still need to teach them Unix when we've got these cool tools? Well, yes, because there's a lot of cool things that you can do in Unix that on demand is just a gateway to. Okay, it's super useful gateway, but these things about composing scripts and automating lots of things, you can't do that with just on demand. On demand is just the gateway. Okay. All right, so I'm gonna just move through the first few of these so that everybody is at least on bridges with the data, and then turn you loose. So follow that link to go to on demand. If I hit that link, it's going to take me to the login page. Should log in. Total aside, but one of the favorite features of my Apple Watch is that Duo is on there, and I can just double click my watch and it gives me my multi-factor. Now if UTA would just get on board with that, because Microsoft Authenticator doesn't work on Apple Watch. So once you're logged in, you should see this screen. Raise your hand if you've made it to this screen. All right. So then we're gonna, I've got fairly detailed notes here. We're gonna click that Bridges to shell access icon, and it will open up shell and ask you for your password again. And I have a note in that document. I showed this, I think maybe the first day of class. It won't move your prompt and it won't show that you're typing anything. It's just a protection, password protection tool that they have built in. But assuming you remember your password, which you must have to get to that stage. I don't know why they make you log in again to the terminal, but you should see a page like this. I don't think I asked this before. How many of you have used a remote HPC before? Anyone? A couple people? I still think it's kind of cool that like that prompt right there, in some sense, is happening in Pittsburgh right now. Like my laptop just turned into a portal to Pittsburgh. A very powerful portal. What does the prompt mean? I guess just to back up a little bit, I don't have this in the notes, but does yours show you the resource when you log in too? Yeah, so that's like the running tally of how many compute hours we have left and how much space we have left as a project, which includes everyone in the course. And we'll talk more about how that how those hours are calculated later when we start doing jobs, submitting batch jobs. So the prompt, right? You'll see your username. The only difference is between what I've got here and what you probably see. So I'm just typing clear to get rid of all that other stuff. So hopefully it can zoom in here. All right, so username, and then it'll say then that's the machine name with a dash, and then the login node. Probably, I forget how many login nodes total, but we're probably not all on the same login node either. That part doesn't matter. I will say this multiple times later as well when we start submitting jobs. We don't really run jobs on the login nodes, okay? But this tells you that I'm on a login node. If I was on a compute node, it would say RP something and with some number after it. And if you remember the cartoon I showed, how there's login nodes and then there's a backend where the compute nodes are. That's in the PowerPoint from last Thursday, I think. That prompt would change, so it would tell you that you're no longer on a login node, for example. Definitely stop me if you have a question. Second task or second unit there is the ls. That is an L. Stands for list. So if I do ls, that's what's in my home directory. Obviously, you don't have all that stuff. But that's how you list the contents of a folder. The third unit, sorry, looking back. The color coding there is telling you that some of those are directories, some of them are files, and then it also has information in the coloring about the permissions of the files. I'll show that again. One of the later tasks has a little more detail.
Is this case sensitive?
Yes, everything in Unix is case sensitive. Good question. Other questions? Did LS work? Yep.
I forgot my password.
Uh-oh.
I just did autosave when I first put it in.
So
Tell me, yeah,
Did on demand? So you couldn't get in on demand even? So you got to this stage, but this one won't work? Oh, your on demand was auto-filled. Yeah, you'll have, so you can try go into the Pittsburgh password reset that we had in those notes before, but yeah, I can't really help with that. It's between you and PSC. Other questions? LS, yeah.
I know you said it's okay for the login node to be different.
Mm-hmm.
How different? Mine is login 011, is that okay?
Absolutely.
Okay.
Makes no difference which node you're on, which login node you're on.
Thank you.
Mm-hmm. Anything else? I really just want to get you to the point where you've got the data, and then you can circle back on any of these that you want to, and I will move around and be answering questions the whole rest of the time, along with Adam and Zoe as well. Finding your path, I've given you some, so the path, that's the directory structure, and showing you either where you're at or where you want to go. I've shown you some cool things to try down there in task 3.1. So the way that this tutorial kind of works is I say, hey, try this, and you should so what happens? What do you think the result is going to be here?
Error.
Why do you think error?
There's nothing separating middle high, so just look at this lobby.
Okay. It's one guess. Anybody else? What do you think it's going to tell me?
Your username?
My username. Whoops, it's off the page. So yes, right? Who am I? JP Damon. That's who the computer thinks I am. Echo home. Anybody have an intuition for what this is going to say? Of course, it says it right on the document, but right. So this is kind of small. So I pasted it, the right. So what is that? Like echo home, what's it doing?
It's your home directory.
Yeah, it's going to return my home directory. So in this case, this less than, greater than u is meant to be username. Sometimes I type out username, sometimes it's just shorthand. Echo project. Okay, I haven't talked yet about the project versus the home, but so if I do echo project, it says ocean projects, and then this bio 2011p JP Damon. Bridges has, well, so first of all, the way it starts with the $, that's just saying it's an environmental variable. This is set up in the configuration of bridges. So this shell has a configuration file. One of the things that it has specified, it's across the whole PSC system, is that home directories are basically on the JET server. This is the name of a server. This is the name of a physical machine. And then in this directory, home, and then everybody has their own username. So that's where your stuff lives by default, the home directory. And it's in this way of specifying with $, says it's an environmental variable, whatever comes next. If you typed something after that $, that wasn't recognized as an environmental variable, it would give you the error, or some error. And then environmental variables are far as I know, always all caps. Okay. So here, I've said, tell me what the project environmental variable is. And that's what echo is doing. Echo is like the Unix version of print. So like print this environmental variable, print this environmental variable. So the environmental variable project is a second directory that we all have that's on a machine called Ocean. Okay? Ocean is a machine that's optimized for input output. It's got a lot more storage space, disk space. Okay, and so when we start moving big data sets over, we'll store these in Ocean in your directory on Ocean. But for now, we're just going to stay in the home directory. We're gonna do all this stuff today in home just to keep things simple. This fourth one, ID, and then the options GN. Everybody should be in the same group because you're all added to the allocation for this course. So our group name is that, Bio 200011P, okay? And so if you look at our Ocean path that it gave us, so the project path, you can see it's the machine, and then it has a separate directory for all the projects that have space on Ocean, and then it has our project, and then everybody has their own account within the project. And I said account, their own folder or directory within the project. So you can try to CD into that. I'm actually not going to do that for the moment. We're going to do lots of CD later. And this notation, group name, what would you fill in there? Yeah, this Bio 200011P, okay? And then PSC username, what would you fill in there? Your username, okay? The double and sign, PWD, that's just bonus. It's just saying after you're done moving there, print the working directory. There's another task coming up, the PWD, to work on that. And then my quotas just tells you about the storage space that you have left. Inodes, which you can think of that like a count of files. So we're limited both in terms of the absolute space, but also in terms of the numbers of files that we can have. The reason that's relevant in bioinformatics is some tools will produce thousands and thousands of files that are tiny. And so actually, I think every semester for the last couple of years, we've hit our inode max way before we hit our total space max. That was a big problem for projects last year. Hopefully that's fixed this year, but. Okay, so hopefully you're in and you can at least have an idea for what the path is. Changing directory. So this is why I skipped it in the little thing above. If we want to change to our project directory, one of the ways we could do that is to type out this whole thing on line number 5. CD and then the full path to our directory on Ocean. I could also CD to this, right? And that is a shorthand way to say, go to whatever is defined as my project environmental variable. So in this case, the path there. So what do you notice happened here? What changed about my prompt?
It added your username.
Yeah, and so where it changed from tilde to username, what is that? Like, if you go up a couple slides in the, or not slides, but a couple pages,
The directory.
that's the directory, yeah. So now I'm no longer in whatever directory tilde is. We haven't talked about that yet. I'm in jpdaemon directory. So something happened when I did cd. It has changed directories to jpdaemon, okay? Now, in the right up here where it did the and pwd, I could have included that and it would have printed the working directory, but let me just do that here. And that printed where I actually am in terms of my path, right? So it did what we expect. It changed directories to my project directory. All right, so I just did the print working directory. You can always go home really fast. There are lots of ways to get home, but if you just do cd enter, see how it went back to tilde? cd all by itself, just cd enter, takes you to the home directory. So just things to play with here. You can try all those on your own. Again, I'm trying to get you the data so you can. So this is U7. Let's get some data. So this is back to Canvas. Download that data tar gz. Go back to your dashboard and click home directory. So now we're going to click this tab with the house on it, or icon. So just as a word from experience, if you try to open a directory and it says there's nothing in there like it did just there, don't freak out. Give it a minute. Sometimes it takes a while for that to populate. I remember that when on-demand first started, and that happened to me a few times, I was very concerned for a while. Like, oh, I've just lost all my data. Okay, so it's there. Two ways to get that. So we need to get the data tar.gz over here to this computer. So for me, oh, I deleted it already. So wherever you have that file, you can drag it onto this window. I can, as an example. Oh, I'm so zoomed in. Right. So I can do that, and it will pop up a window that says upload one file, and then you can click upload, and it may take a minute, but you should end up with data tar.gz in that window. The other way you can do it is to click that upload button, which will, again, you can drag and drop that, or you can use the browse icon. You guys know how to use GUIs, so. This is the part of the course that even if you were in it 2 years ago, we would have had to learn to do this command line style with the CP command. That was not fun.
One time through the terminal, I wiped my entire directory. It's not fun.
Yeah. Command line can be very powerful, but also very dangerous. I will try to warn you in case, if there's danger ahead. Okay, so how many people have gotten it uploaded? You got it? All right, awesome. I typically, when I'm trying to work through a tutorial, I'm looking for 2/3. I know it's frustrating to sort of be left behind, but this way I get to a point where I can just turn everybody loose, and then I can circle around and we can help individually. Okay, the last step here before I do turn you loose is extracting that on bridges. So go back to your terminal, and if you're in your home directory, and if you're not sure, right, you can do pwd to see if you're in your home directory, or you can always just do cd enter and know that it will take you back to your home directory. And since that's where we just moved the file, if I do ls, I should see data.tar.gz, and it should be colored red. That's the default theme colors. The tar balls is what these compressed files are called. By default, it colors those compressed files red. All right. I've given you some of the background and the explanation for what the command is going to do, but in task 8.1, where I've already gone to my home directory, now I'm going to execute this command. So tar-x is for extract. Z tells it use the gunzip method, or the gzip method, but g unzip. I don't know why. I call it gunzip, whatever. V is for verbose. F is I'm going to specify the file here. And if I hit that button, it's going to extract whatever's in that compressed file into my home directory. Okay. I've already done that. Actually, let me. Nope, it's not. You should see, because you put it in, the V said verbose mode, it's going to tell you all the files that it's extracting. So you should see a list of what it's unpacking into your home directory, okay? And it's showing you the path that each one is going in. Then you can hit CD. Whoops. So it says use CD and ls to explore. So if I want to go into the directory that just got unpacked, what do I do? How do I get there? Tell me what to type. CD data. Yep. Whoops. Not with caps though. And again, it's case sensitive. I did that intentionally just to help you learn that everything's case sensitive. Very good question earlier. Right? And so see how the prompt changed? So it is in fact in the data directory now. If I do ls, you can see I've got an Arabidopsis, a GenBank, a miscellaneous, and a Unix test files folder. Okay? The last step there is going the other way. So this is saying use that tar command. -C tells it to compress. Instead of extract, we're going to compress. So right, tar-c, use the gzip method in verbose mode, and the file that we have to tell it the file name that we want it to write in this case. Whoops, arabidopsis.tar.gz. Right, that doesn't exist. That's the file we're going to create. And then what are we going to put in that file? We're going to put in this directory Arabidopsis. So if I hit execute, you get the same thing, but this is now happening in reverse. It's taking all the stuff that's in that Arabidopsis directory and it's going to pack it into one file. So it's finished. I've got my prompt back. If I do ls again, now I've got this new file here called arabidopsis.tar.gz. And then there's this cartoon that is just so true. Next time you need to extract or compress a file, you are not going to remember -xvc or -x. I've already forgotten. ZVF. Okay. So, any questions? This is the point where I'm going to turn you loose. The idea here is that you're just working through these. This is a very dense document in terms of information. So even though to get to this point I've kind of been skipping over the text, there's a lot of text there meant to help you understand what's going on. And then there are tasks set up. Don't skip over the tasks if you really want to learn how to do this stuff. Don't be afraid to mess something up. Explore. That's the way you learn in this kind of environment, right? I wonder what happens if I try this, okay? Some of them are explicit. I say, try this. But, I mean, things will occur to you to try. Go ahead, try it. What you need to do by next Monday at 11:59 is this afternoon I'll post a Unix quiz. That Unix quiz is meant to assess whether you understand this solution to 27.1. Okay? And I have it in bold right there at the end. If it's not clear, use ChatGPT to help you understand it. I don't back to the beginning of this document. It's a lab partner and a tutor. Use it, okay? If you just use it to have it explain 27.1, you're going to end up frustrated later because I'm going to assume that you at least are functional in this Unix environment, okay? Questions? Yep.
Is the quiz over the commands that it took to get there, or is it more like what? So what is?
The quiz looks like it gives you part of the command and says, here are the options, what does it do? Which one does this do? Like it's a matching thing. So that's one example of. There are also some why questions, if I remember right.
And so for this 27, we're going to be, it's in our file, and we're just using the commands within the document.
Yep. This tutorial is all, there's nothing really for you to figure out here. It's all teaching, okay? With examples, because I think part of the teaching is see how it works. Until you get to 27.1, where it says try to break down each step and work it out, okay? And rather than give you the step-by-step, I've said if you don't get it just from what you've learned up to that point, ask ChatGPT, because that's the way the semester is going to go. Okay?
You're saying don't use ChatGPT to explain it to do what instead?
I am saying use ChatGPT to explain it if you don't get it. So if I was saying once you've gotten to that point in the document, that command line should make sense if you sit and think about it. If it doesn't, ask ChatGPT for help. Like, I don't understand what this is doing. You can even give ChatGPT the data file because it might want that to really understand what's happening there. I haven't actually tried going like, here's the data file and here's the question, the biological question, and see if it gives me that Unix line. Probably not. There's too many options to potentially solve the problem, but I'm sure it can tell you what's happening in that line. All right. I'm here. I have office hours Monday and Wednesday from 12 to 1, right? So there is another chance outside of this class to, if you have trouble over the weekend with this tutorial, there's at least one more chance to come see me. Okay.